Good morning, good afternoon, ladies and gentlemen. A warm welcome out of my home office here in Germany. In Germany, it's 7 p.m. right now. It's pretty bad weather, so it's rainy, it's rather windy today, and it's 14 degrees C or about 54 F. So it's a good time for having a web seminar staying at home. So thank you very much for your participation today. We really enjoy that you join our first day and the first session of our 3 days web seminar. My name is Anne Drewer and I'm the global head of the NQ's Home Care and Industrial Solutions. And I'm your host during the 3 days of the seminar. Just a few words about me. I started with BYK on the 1st of May 1994, came from BASF, and last Saturday I had my 27 years anniversary with the company. I started that days as a lab manager for wax additives and became for about 12 years the product group manager wax additives globally later. In 2010, I moved into the NQs, so being responsible for sales and marketing globally. First of all, for the NQs called Wax and General Applications. And when we acquired the Rockwood rheology additive business in 2014, the focus of home care came up, and so we renamed the NQs into Home Care and Industrial Solutions. I'm located in Wesel, and under normal circumstances, I will travel around the world and we will meet on conferences, exhibitions like the ACI or the HCPA, or even in your companies and having a face-to-face chat during my travels with my colleagues. Yeah, but nowadays, unfortunately, it doesn't work out, but really looking forward that next year everything becomes more back to normal and we will be able to see each other face to face. But I think it's a great opportunity to have this possibility during web seminars nowadays and having the chance, staying close to you, getting in touch, and so we really hope that we can stay in touch even after the seminar. So please feel free to contact us anytime if you have any questions or you want to discuss any idea or challenge you have in your daily work. And I'm really glad telling you that that's the advantage of such a web meeting. So we did it this morning even for Asia and Europe. And so in total, I'm talking to participants out of 65 countries today, and that's really amazing. So thanks really for joining and your interest in our seminar. So before we start the technical lecture, I would like to introduce our headquarters in Wesel to you, to give you a certain idea how it looks like. And maybe that you never heard about the city named Wesel. Even some Germans wouldn't know it because it has just 50,000 citizens. It's close to Düsseldorf. That might be a city you have heard before. We have the international airport there, and it will give you a certain idea where we are located. Yeah, but first of all, let's start having a look to our video.
You see from the bird's eye view the headquarters of BYK in Wesel, Germany. BYK is the biggest division of Altana Holding. We are organized in 5 business lines. The NQ's home care is belong to business line industrial applications. To give you some numbers, in 2020, BYK had a turnover of about €1 billion. BYK was founded in 1873 by Mr. Heinrich BYK. That's the origin of our company name. In addition to our site in Wesel, we have production facilities in the Netherlands, the UK, USA, and in China. We love to stay in close contact with you. Therefore, we have local service labs in most countries to offer you technical support in local language and next door to your company. Innovation and sustainability are the drivers for our R&D departments with over 200 employees in Wesel, China, and the US. Our biotech lab in Wesel is providing expertise in technology platforms like bioadditives and new raw materials. Wesel became the home base of BYK almost 60 years ago. I even like to introduce my team to you. Our lab in Wesel, Ralf Koch, who is more than 30 years with BYK. Petra Lutz, with 20 years of experience. And our youngster, Daniel Kolipost, who started 2 years ago. In the NAFTA market, you will be supported by our American team, Shannon Morrison and Eddie Carruthers. We all love to support you and looking forward to staying in contact with you. You see from the bird's eye view the headquarters of BYK.
So I hope you got a certain impression about Wesel, Germany and our headquarters over there. But as I mentioned in the video, next to Wesel, we even have facilities in the US. So our headquarters, our American headquarters, is located in Wallingford, Connecticut since 1964. So they started a bit later than we started in Germany. And that is the place where our R&D and even the HI service lab is located. And today, of course, even due to the timing, my American colleague will support me during this web seminar. And of course, you will see much more about Shannon as the local end-use manager for the NAFTA market and Eddie, who's supporting us in the lab during these next days. For today, we started with my colleague Brent Lorenzi. Brent will introduce to you the surface additives and will explain you how to achieve perfect substrate wetting. Brent serves as the applied technology specialist for surface additives in North America. Brent has been with Altana for 21 years, joining the BYK team in 2016. He's located in Louisville, Connecticut. So Brent, please take over.
Right. Thank you, Anna. So can you hear me?
Yes, we
All right,
can.
perfect. And can you see my screen?
Now I see you.
You see me? Oh, well, this is not good.
Oh, I like it. So, but of course,
We did our test to see the screen, and it's not the screen wasn't showing properly. So my apologies. Let's try this one more time.
Yeah, you will manage it. Ah, perfect.
All right, so you see the screen now?
Yes, we do.
Okay, perfect. All right, so thank you very much, Anna. So today, as she mentioned, I'm going to talk about the surface additives here for BYK. So we're going to talk about 3 sections. We're going to talk about the just a review of surface tension, and then we'll also talk about the substrate wetting and the difference of flow and leveling, and then we'll talk a little bit about the silicone-based additives toward the end of the presentation. So first, just a moment mention of surface tension. And what is surface tension? So surface tension, we're typically talking about liquids, and I'll just go ahead and say that we'll use the term surface tension and surface energy somewhat interchangeably in today's talk. But typically surface tension, we're talking about the liquid, and the surface tension are all these cohesive forces inside the liquid. They kind of compensate each other, and there's no resulting directed force. But as you can imagine, as the liquid at the air interface of the liquid, now the forces are directed more inwards towards the liquid and away from the air. And so this is what helps give a liquid the spherical shape when it's suspended. But now typically in our line of work, we're dealing with liquids that are then being applied to some sort of surface. And so once the liquid comes in contact with the substrate, now we have both the cohesive forces inside the liquid pulling inward towards the liquid, trying to make this spherical shape. And in addition, you have the adhesive forces, which are trying to pull on the liquid to get it spread out over the surface of the substrate. And so typically what we want in our applications is we want good wetting of the substrate. In this case, in order to achieve good wetting, we want to have the adhesive forces be stronger than the cohesive forces, so that it pulls the liquid over the substrate. Okay. This is typically, instead of talking about adhesive and cohesive forces, we often talk about the differences in surface tension and surface energy. So here you'll see what we typically want is we want the surface tension of our liquid to be lower than the surface energy of our substrate. And again, this is where we typically use these terms surface tension and surface energy similarly, but technically speaking, the surface tension is referring to the liquid, the surface energy is referring to the substrate. And so in this example, we see our surface tension of our liquid is higher than the surface energy of our substrate, and it tends to bead up. Right? The higher the surface tension, the bigger the bead. But as the surface tension starts to drop lower and lower, you see the liquid starts spreading more evenly over the surface. And once we reach a point where the surface tension is below the surface energy of our substrate, this is when we say we've achieved kind of an ideal wetting. And so this is where additives typically going to come into play. It's going to allow us to modify our liquid in order to achieve the right surface tension to wet out our substrate. Okay. When we're talking about surface tension, it's really made up of two parts. There are dispersive parts and polar parts. The dispersive parts are typically the weaker interactions that we're dealing with, typically like van der Waals forces. The polar forces are much more stronger interactions, the dipole-dipole interactions, hydrogen bonding, etc. And you can see to our graph on our right, we have some different materials we typically may be dealing with in our everyday work. So on the left-hand side, you see materials such as water, which has probably the highest surface tension of just about any liquid that we're going to be dealing with on a regular basis. And its surface tension is in the approximately 72 millinewtons, compared to something like an aqueous emulsion as delivered before additives are put in. May have a surface tension somewhere in the mid-20s or near 30. Also, you see several different substrates that we might be dealing with, maybe a PE foil or teak wood or PMMA. Various substrates all have a polar and dispersive parts. So now the difference, why the polar and dispersive parts are important, come into play a little bit more with adhesion. And you can probably imagine if we're looking at something like silicon paper, you'll notice silicon paper has almost no polar parts, and this would probably be the more difficult substrate in order to get adhesion to, where something like beechwood with its high polar parts may be a little bit easier to achieve adhesion. But we're not going to focus so much on the adhesion today and talk more about the actual wetting. Here's another way to look at some of the different materials we work with in our general work, formulated coatings. Again, look at some of the solvents. You can see there's a pretty huge difference of different materials we may work with. Clearly, again, on the waterborne side, water being the highest surface tension material that we work with. And on the opposite end, like an organic solvent such as white spirits, may have a surface tension in the low 20s. Also, we have different resins as they're supplied, whether it be an acrylate or some sort of waterborne emulsion. Again, the surface tension can range anywhere between, in the mid-20s to 40s. And then on the right-hand side, you see some of the different substrates we may be trying to coat. for welding applications. And you notice that the our dance floor is probably the most challenging material to coat. It also has the lowest surface energy. So you can imagine if I'm trying to take a waterborne coating that has a surface tension of, let's say, 35, and I'm trying to coat my dance floor, which has a surface energy of in the low 20s. And as we stated before, we need the surface tension of our coating to be below the surface energy of our substrate. And so this is quite a large difference to be able to overcome. And we typically are going to need additives in order to overcome this, so we get good wetting of our coating on the substrate. And when we're talking about surface tension, there are three tests that we can use, and we have these capabilities in labs both in our Wallingford, Connecticut headquarters in the U.S. and of course at the headquarters in Basel. So these are tests that we can certainly run for customers to help get a little more scientific view of what is going on. So one test you may be familiar with in order to look at the surface tension of a liquid is the so-called ring method. This is the so-called Denoy ring, where we immerse a platinum ring into the liquid, and then this instrument pulls the ring out of the liquid. And you'll get to the point where the meniscus here on the sides will start to break. And we can, of course, graph the amount of energy that it takes, or force that it takes, to then break this little meniscus. And at the top of the graph, you'll see on the right, at this point, this is where the liquid will break. And at that point, that's the point that is determined to be the surface tension of that liquid. So this becomes a really fantastic tool for us in trying to diagnose, well, what additives we need to achieve, went too far, sorry, to achieve the right surface tension to wet out the substrate. We also have the ability to measure the so-called dynamic surface tension. This comes into play quite a bit more for high-speed applications, and it's very famous in like printing inks. So you think an inkjet application is where it's used primarily, but also comes into play for different spray applications. And in this test method, we're inserting a capillary into the liquid, and then we're intentionally creating a bubble. And the amount of force used to create this bubble, we can then measure this, and then the bubble will come to the surface and eventually break in this, and then we can also choose then the rate of how quickly the bubbles form. And essentially in this method, we want to figure out how quickly the bubbles get to the surface and break. And again, this becomes very important in these high-speed applications. Again, thinking inkjet application is again the most famous, where the coating has a very quick amount of time from application to dry. So there's not a lot of time for the additive to do its job. So it's very important for the additive to work quickly. Whereas if you were painting your home, for instance, or maybe on a floor polish, where maybe you have a little bit more time for it to dry, the additive can have a little bit longer time to do its job. So this becomes a really nice test. Well, and again, it wants to go too fast. And then finally, the substrate becomes important. So the idea of measuring the contact angle is equally important. You need to know the surface tension of your liquid, and now the surface energy of your substrate. And so we do this by placing a panel in instruments, and we put micro droplets of different liquids of known surface tensions on this substrate, and then we're measuring the contact angle. So products that have a very high contact angle have where the liquid is beating up. This is going to show not so good wetting, and then of course the lower the contact angle becomes, the better the wetting is. And again, so by using this information, this allows us to put a little bit more of a scientific view angle to trying to solve the problems for you in terms of what is the best additive to get proper wetting on my particular substrate. All right. Another topic that we tend to talk about at the same time as wetting is also leveling. And wetting and leveling, we tend to talk of them as the same thing, but they're really quite different. They really kind of work against each other. So what is leveling, or what influences leveling? So different things can influence leveling. So the rheology plays a really important part in leveling. How much time your coating or your polish has before it cures plays a big role. And of course, surface tension also plays a role. So what improves the leveling the most, a high or a low surface tension? And this can be a little bit counterintuitive, but really the smallest surface area is going to give the best leveling. And so here's an example we show with mercury. Mercury probably being the highest, the liquid with the highest surface tension of any materials that we know. And this is giving really perfect leveling. I think another example I often give that people can relate to is if you had a piece of paper and we tried to take this piece of paper and we have it folded up, and this is not really good surface tension. We want it to be smooth. So how do we get it smooth? We put tension on the paper at the different corners to try to help smooth it out. So actually a higher, why for good surface wetting, we want a lower surface tension. For good leveling, we need a slightly higher surface tension. So it's always a balance in our formulations to get the right amount of wetting along with the right amount of leveling. So what can we do to improve the leveling? Different things, and we're not going to get into all of these today, but one, at a basic level, we want to make sure that if our system is pigmented, that all of our solids are properly deflocculated and stabilized in the system. Again, we can also modify and optimize our solvent time, our solvent blends. Also, our resin choices play a big role. But of course, today we're going to be talking about what additives we can put in our formulation to help further optimize this. Okay. So there are really three situations that we run into when we're talking about coating a surface. Okay, and again, remembering we want our surface tension of our liquid or our coating to be lower than the surface energy of our substrate. So in this situation, in situation one, we have a situation where our coating has a surface tension of 33 millinewtons and our substrate has a surface energy of 30 millinewtons. So in this situation, if we applied the coating, we would expect that the substrate would not be wet out properly because our surface tension is too high. We would have poor flow. And you might be able to see in the background the yellow coating in the picture is clearly not wetting out this substrate very well. So if this is our situation, we know what our plan of action should be. Now we need to reduce our surface tension further in order to get proper wetting, and then we can come back and then adjust flow and leveling with maybe a less active silicone or a polyacrylate later on. In situation number two, this would be kind of the ideal situation where now our surface tension is 29 millinewtons, which is just barely below the surface energy of our substrate at 30. So in this situation, we would expect to have really nice substrate wetting. So in this case, we may or may not have good flow and leveling. So if we need to make some adjustments, again, we might change the activity of our silicone or again, come back with a polyacrylate. But I would expect in this situation that we're probably in pretty good shape. But again, some adjustment may need to be made for ideal leveling. A lot of people in traditional coatings applications will say, well, if I need to have my surface tension of my coating lower than the surface energy of my substrate, well, why don't I just make the surface tension of my coating as low as possible? And so in this case, we have a system with a surface tension of 25 millinewtons coating on our surface energy of 30 millinewtons. And again, we're going to have really good substrate wetting because the liquid, our coating has a lower surface tension than our substrate. But in this situation, the difference is too large. And often this is going to result not only you will get good substrate wetting, but now you probably do have really poor leveling. And in this situation, again, there's different actions we could take. We could maybe reduce the amount of our additive to increase the surface tension, or we could use a less active additive. And again, you could always then also come back with maybe an acrylate or some other chemistries to help improve the leveling. But this is a really good way. These are three scenarios that we're most often going to be faced with, and a good prescription for how to address each one. Okay. All right, so that's a little bit about the theory on substrate wetting and leveling. Now let's talk a little bit about the chemistries we're going to use and the additives we're going to be talking about. So probably the additive that comes into play most often for improved substrate wetting are the so-called silicones. And so just so you know, when we're talking about silicones, we're not talking about straight chain silicones. We're almost always talking about the polydimethylsiloxanes. And the polydimethylsiloxane is a very useful molecule. We have the tremendous number of products based on this chemistry because it is so useful. So you can see here the basic building block of a polydimethylsiloxane. And by controlling the molecular weight of this additive, we can control what effect it may have in our formulation. So if we have a very low molecular weight here between 2 and 27 units, these are going to be a little bit better for leveling. If we increase the molecular weight between 45 and 230 units, now we're talking a little more about surface slip. You start getting much higher, now it gets to be a little more incompatible in the system, but you get better defoaming action. And if you get too high, above 1800 units, now you get this so-called hammer tone effect. And so BYK has a large number of products in the leveling, surface slip, and defoaming categories. We don't have any products that are in the hammer tone. Those are a little bit more unique, often more for powder coatings and some special liquid coatings as well. The polydimethylsiloxane molecule is also very, very useful because we can modify it. And these modifications can give us some other interesting functionalities. So very often we're going to use an organic modification. And this could be a polyether, it could be an alkyl group, polyester, or a variety of reactive groups. And this gives us, again, a lot of flexibility depending on what the application is and in certain functionalities. We also have the ability to change the number, of course, as we said, the number of the siloxane groups. And depending on the length of these chains, we now can control the compatibility for water and different polarities of systems. And also this is how you control the amount of surface slip versus less surface slip. So you can see with a fairly simple molecule, there's a lot we can do. And this also gives some insight as to why BYK maybe has, some people say, oh, you have so many products. And this is why. We can customize the products based on these different modifications in order to give just the right properties for a variety of formulations. Okay. All right, so focusing a little bit on the solvent-based systems now with these with the polydimethylsiloxanes. Here's just a small sampling of some of BYK's products. And just to give you an idea of some of the properties that they're going to provide. So if we're talking about reduction of surface tension, we have products on the one hand, something like a BYK 320 on the top hand side, where you can see that even at a relatively high dose, it's going to reduce your surface tension to maybe 29 millinewtons, which may be sufficient for certain applications. There may be other applications where you're trying to coat a very low energy substrate. And for instance, there could, again, maybe like the dance floor, in which case you may need something much stronger like a BYK 378, which has the ability to reduce the surface tension down to 25 or below. And again, please, these numbers on the surface tension are not absolute. It's going to be slightly different based on your formulation. So there could be a couple of units difference here, but in general, the trend is always the same. BYK 378 will reduce the surface tension to a much larger degree than something like BYK 320. Also to note that you need to always consider the dosage of the additive. Typically, the higher the dosage, the stronger the effect. But also be careful because too much is also not always the best for a particular formula. I like saying some of our additives are a little bit like Goldilocks. You don't want to have too little of the additive in our formula because it won't do the right job. And you don't want to have too much because it might cause some other issues that we don't really want. So you want to find just the right amount. So you'll always hear us talk about doing a ladder study for the additives to determine what is just the right amount for my particular formulation. So certainly encourage you to not go and just put the maximum level recommended on the technical data sheet in your formula and see if it works or not. I would always choose at minimum 2. Ideally, you would choose 3, but at minimum, I would choose at least a high and a low level and see where am I at and determine, do I have the right additive to achieve what I need? All right. So here we're going to see just what good substrate wetting, how powerful these additives can be. So again, here's a liquid coating where it's going to be applied over a metal substrate. And on the left-hand side, you have the coating without additive. And on the right-hand side, we have the coating with only 0.1% of BYK 333 and drawing down with a wire rod applicator. And as you can see already, it's very clear that the coating on the left-hand side that does not have the additive clearly does not wet out the substrate, and it looks really, really poor, versus the coating on the right-hand side that has again, only 0.1% of the BYK 333 wets out the substrate quite nicely, and it gives us a nice even film, which is what we're shooting for. Now, another reason we might use silicon additives in our formulation is to improve the surface slip or lower the coefficient of friction. And so this can be measured, of course, and here we're going to show you one of the ways we can actually measure it, this instrumentation we have in our labs. All right. And in this situation, we take a panel or whatever our substrate is, you place it on the instrument, and then we'll take a weight of defined weight, and usually experience kind of tells us which weight we should use. But in this case, I believe this is maybe like 500 grams. And we're going to attach it via this metal rod and turn on the instrument. And the instrument is now going to pull the weight, drag the weight across the surface. Now you'll also notice that there are small metal balls on the bottom of the weight, and this is to help ensure that we don't damage the substrate, because we don't want to be like a knife edge and gouge into it. But as we're pulling this weight across, you'll see this little recorder here to the right is actually recording the amount of force that's used to pull that weight across the surface. And then when we're done, we can interpret this data. My apologies. And you'll have your coefficient of friction. So this is again another. Oh, there we go. Another way we want to property we want to put on our coating. And so here's another graph. This is really the inverse of the graph we saw before, where we're looking at the surface slip. And you'll see now that the BYK 378 is on top and the BYK 320 is on bottom. And again, so in this case, the BYK 378, ironically, this lowers the surface tension the most, and it also provides the most surface slip. Whereas the BYK 320 lowered the surface tension the least amount and also provides the least amount of surface slip. Now, I'll back up one real quick. Now, something to be said is many of these products can be used in both waterborne and solvent-borne formulas, such as the BYK 378. But the BYK 378, why it can be used in waterborne, may not be the best choice for a waterborne system. So we introduced a product last year, the BYK 9890, which is an aqueous emulsion of a silicone for car polishes. And this is a really nice product. It's applied at 22.5% in non-volatile matter and water. It's APO and VOC free, and is really excellent for water repellency, dirt repellency, and improving the slip of our car polishes. So this is a really great product. If you're not familiar with this product, I certainly encourage you to get in contact with your local BYK representative. They can tell you a little bit more about it and arrange free samples as well. Okay. Just another note on some of where many of the BYK additives can be used in car care formulas. Certainly there are room for wetting and dispersing additives that are going to be great, help you make a more reproducible product in terms of color. There's room for rheology additives and wax additives, but obviously today we're focusing more on the silicone and additives, and where they're really providing the benefit they're really providing in the car polish is this easy polishing, improving the gloss and shine, and again also providing a high slip where it's necessary. Right. And here's an example. A really nice example of an old Volkswagen bus hood our colleagues went out and found, and I was kind of lucky they found that it was red, because red, at least older red colors, are some of the more difficult colors to maintain good color stability over time and good weathering. And so you'll see here on the right-hand side, the hood in its kind of original found condition. And then on the left, 2/3, we have polished it up with some of our internal starting formulations. And you can see we've really brought the hood back to life with our polishes, really nice gloss and shine. And again, if you have some questions, we'll be able to later on contact your BYK representative. We'll be able to get you some of these starting formulations and help you improve some of your own polish formulas. Okay. Just real quick, sometimes people ask, they're really interested in the coefficient of friction and how much slip, but they don't really have access to the instrument that we showed previously. So here's a very simple test method that you can use just on your benchtop. This is where we take some different panels. You put a weight on the panel and lift the panel up to a particular angle, and you're kind of watching how easily the weight slides down the panel. So you can see if the panel here in front was at a much lower angle, the weight slid off very easily. The panel here in the back, we're lifting up to a much higher angle, and the weight doesn't slide down at all. It actually kind of falls off to the side. And even though this isn't very quantitative, it's more qualitative, it gives you an indication, am I improving slip? And certainly don't worry if you don't have this particular weight. The way we used to do this in the lab all the time is we would just take a coin and you put a coin on the panel and run the same test. As long as you're using the same coin on all the panels, you get a pretty good indication, am I improving my slip or am I not improving my slip? So, and of course this will work in the reverse as well. If you're trying to formulate a floor polish where you had low amount of slip, obviously something like the instance in the back would be more preferable than the panel up front. All right. Okay. So now when we talk about waterborne systems or aqueous systems, now we're talking more about silicone surfactants. These are going to be much more effective than the polydimethylsiloxanes that we were talking about previously that are much more effective in solvent-borne systems. And these silicone surfactants are much shorter chains with some sort of polyether modifications on the side. And these polyether modifications are typically just ratios of EO and PO in order to adjust the polarity and the compatibility in the system. The silicone surfactants work much more at the liquid substrate interface, and are going to be very, very efficient in terms of lowering the surface tension of an aqueous system and help wet out the substrate. As you can see here, they're going to be very, very comparable to fluorosurfactants. Many of you probably know fluorosurfactants were probably the best material for reducing surface tension for a number of years. Even though they have their downsides in stabilizing foam, they're still very, very effective. However, due to a lot of regulatory pressures, as most of us may be well aware, the fluorosurfactants are finding less and less use. More of them are getting banned. So the silicone surfactants actually now become the much more of a greener alternative to fluorosurfactants when you're trying to improve substrate wetting. Also, just notice here the modified silicone toward the top. This would be similar to this is going to be the polydimethylsiloxane we were talking about before. And you can see it certainly doesn't lower the surface tension nearly to the degree, doesn't improve surface wetting nearly to the degree as the surfactant does in the waterborne system. Here will be a video kind of showing this effect. Again, we have just a drawdown card here where we're putting a few drops of water on both of them, and then to the water on the left hand side we're going to be adding just a couple of drops of a product like BYK 333, and you're going to see how the water droplet does start to spread out. So that's not bad, but now you look at on the right where we're adding a surfactant similar to like a BYK 349, and you can see the dramatic improvement in the wettings, significantly better wetting with the silicone surfactant compared to the polydimethylsiloxane in the aqueous system. And so here in a real life example, in a floor polish, we have a system on the left-hand side. Again, we tried maybe a little bit of a ladder study at 0.05%. We saw that we do not get good wetting over this particular substrate. You can see it looks very, very, very poor performance. Whereas on the right-hand side at 0.2%, we get really good wetting of our polish, and it looks very, very, very smooth. And in this situation, if I witnessed these results in the lab, I would probably come back and even try a little bit lower level, maybe 0.15 or 0.1, again, to try to find that just the right amount of additive to give me the ideal wetting performance on my substrate of choice. Okay. Here's another example on a floor polish. And this is a situation where we put multiple layers of polish on in a certain pattern, and at the end of the pattern you can see we kind of intentionally put a big X made a big X with our polish at the end, and you can see the control with no additive. You can clearly still see the X, and if I saw this on my floor I probably wouldn't be very happy. It's not a very good performance. But in the situation where we've optimized the formula with 0.2% of the BYK 3450, you can see if you look really close you might be able to see the faint outline of an X. But clearly there's a huge improvement in this particular floor polish with the 3450, improving the flow on the dance floor to give a much smoother appearance of our polish. Now we have kind of a unique challenge here in North America with how floor polishes are put on, and it's kind of the common practice. In different parts of the world there are different Again, different practices in terms of how many coats of the polish we put on. And also we found out that also another problem we come up with, we do something in the lab on a single floor tile, and then maybe it looks really good on the floor tile, and then we go to do a trial on a much larger surface area, and well, it doesn't look so good. Well, for sure, if we do a trial in the lab on a single tile and it doesn't look good, if it goes to a larger surface area, it's not going to look good. But it does become a problem if it looks good on one tile. You don't want a customer to go and trial an entire room and potentially it fail. So we developed these little frames, these little wooden frames. We put a much larger, we can put 9 tiles in. And this is where we did this in our Wallingford laboratory to kind of simulate a much more real life scenario where we're applying a polish with a mop. So, and something else that's really unique in the US, you'll see, is that we often put up to 8 layers of the polish on the floor, which I realize is quite a bit more than other parts of the world, but that becomes the convention here in the US. So this becomes our working area. All right. And just kind of show some of the differences here. Here you're seeing on the right-hand side in the wood frame. Here's our 9 tiles, and what you're seeing on the left-hand side is we've taken a single tile out. And for example, here we have a control system with no additive, and on the bottom you're seeing an additive with only one additive, 1 layer. And what you're kind of looking for is kind of the distinctness of image, and it's kind of hard. It is kind of challenging to see on the screen. I think it's sometimes maybe easier once you get the presentation afterwards to look at it. But I think you can sort of make out the image here in the light is maybe a little bit better here with 1 layer. Here with 8 layers, which is more conventional, the application in the US, I think it's a little bit easier to see when you're looking at the single layer here. Now it's quite easy to see this is Eddie, who, if you haven't met, I think you'll hear from him in the coming days, where he's taking a picture. You can much easier see him, his arms here holding the camera, taking a picture. It's a much clearer image than up above. So you can see here where our additive is making an improvement in this particular floor polish. Here's another way to look at it. And here we have a ruler down the center. So again, if you look real close, again, we're kind of looking for this distinctness of image, or how clear the reflection is. And here you can only see the ruler down to a certain point where the image is relatively clear in the control without our additive. And then on the right-hand side, you see a product where we have an experimental additive where we put in, and you can look at the distinctness of image, and you can see much farther down the ruler, so you can much more easily see the improvement. I think it's also possible if you look here on the edges, off to the right or left, you can certainly see here the control with no additive. It's quite easy to see some of the wrinkles and how unsmooth this coating is versus our panel on the right. If you look in the corner, it's a much smoother image. Okay. So again, talking about these differences of surface, why you would use a silicone surfactant instead of a polydimethylsiloxane. Again, big reason becomes surface slip. So products like a BYK 349, which is with these silicone surfactants, is not going to reduce the coefficient of friction. And of course, if you're working on a floor polish, certainly you don't want a high level of slip. This would be a safety hazard per se. Now your kids may like this if you polished your floor at home, and they might have a little bit of fun sliding across it. But certainly, if you were going to the store, you wouldn't want your floor to be quite that slick. It wouldn't be so fun if you fell on it. So certainly, we want to have additives that are going to provide good surface wetting, but not lower the coefficient of friction too much. And so a product again like a BYK 349 will do an excellent job of again, helping wet out the surface without providing slip. Whereas a product like BYK 333, again, it's probably not going to do as good a job wetting the surface, but it is going to provide slip. Now, I just will interject here. It is very possible in formulas to use both of these types of products in certain formulations. I know there are traditional coatings formulas that I've worked with much more in the past where you might use both. You may use the BYK 349 because you want good wetting out of your surface, and there may be applications where you also want a higher amount of slip, and so you may use the products in combination. So again, you always have to kind of balance out the property you need. And again, always would certainly recommend you talk to your local BYK representative, and they can help walk you through, well, these are the additives that are going to be best for this particular application, and maybe certain combinations you wouldn't have thought of may give you some really ideal properties. Okay. Here, just another word on the dynamic surface tension. We mentioned a little bit before, just maybe a little bit another way to look at it. If I have my coating or my formulation in a can or container, and all the additives are on the surface, and while all the additives are on the surface, which is kind of where I want them, that's where I want the additive, I have my surface tension optimized, in this case, to 35 millinewtons. But now what happens as soon as I stir it? Now all of a sudden I've stirred up my coating, and then all of the additive that was on the surface is now in the bulk. And in this case, we can assume this is just straight water, because now my surface tension is now increased back to 72 millinewtons per meter. But at some point, all those additives are going to come back to the surface. And over time, the surface tension is going to go to 55, and it'll be a gradient all the way back to getting back to where I started at 35 millinewtons. And how quickly this happens, again, can be really important depending on the application. When it is really critical, there are some special products that tend to work faster than others. So we have so if you look at products like a BYK 349 or BYK 345, which are going to be very common surfactant, very popular, very common products, that are going to do a really great job at lowering the surface tension and provide really great wetting. Well, they don't necessarily work as fast in a dynamic environment. And so you can see here, we're plotting surface tension, and we're plotting it at rest versus a certain amount of energy into the system. And you can see with the blue lines that, over time, the 349 and 345, for instance, are not recovering very well. And so your surface tension, stays a little bit higher than you may like for a particular application. So if you had an application that was this high speed where you really needed really quick recovery, we have a product such as a BYK DynWet 800, and this is a slightly different chemistry. It's an alcohol oxalate, and it's going to be very quick. Now on the positive side, it's very fast. It's going to be able to keep your surface tension, somewhat steady under very high shear conditions. On the downside, it doesn't get the surface tension quite as low as you may want. So whereas the DynWet may only get you down to 30 milliliters per meter, whereas the 349 or 345 can certainly get you in the low 20s. So again, this is where you have to kind of balance out the properties of what is desired for the application. Okay. So again, for waterborne systems, here's some of our basic recommendations. I think a product like BYK 349 is always a fantastic place to start. It probably has some of the widest compatibility of the silicone surfactants. You can use it in straight water systems. There's no benefit to having co-solvents. Products like BYK 345 and BYK 346 tend to be a little bit more effective when there's some co-solvent in the system. And then we have some of the other chemistries here as well. I won't get into all the recommendations today. But in summary, we kind of talked about two different chemistries. We talked about the silicone-based surface additives, the polydimethylsiloxanes. Again, much more prevalent in solvent-based systems, although some could be used in water. But these are very useful molecules. They can have a wide range of silicone units, between 10 and 100 SI units. They're really great at reducing the surface tension in solvent-borne systems. They can really increase slip, and these are going to be used a lot. You're really going to use these quite a bit in like a car polish situation. Whereas on the waterborne side, you're looking more at the silicone surfactants. Again, much shorter silicone chains. They're really excellent at reducing surface tension without giving an influence on surface slip. So these are going to be much more useful in floor polishes, again, where you want that really great leveling. You want it to look really excellent, but you don't want any slip to be imparted. Okay. And with that, I think we come to the conclusion. I thank you for your time and attention, and I believe we have some time. We may have some time for some questions. So,
thank you, Brian. Yes, we have some questions. So one question for you. There are many surface additives of BYK. How can I decide which one is the most suitable for my application? Was one of the questions from the audience.
This is an excellent question, probably our most popular question, probably in all end uses, I would think. And I guess there are kind of multiple answers to that. I mean, one, if you're not familiar with our website or the BYK app, we certainly encourage you to go to check that out. I think most of our customers will say that BYK has one of the best websites and one of the best apps in the industry in order to find information. You can look at our product guide based on the end use applications. There's a lot of starting formulations out there as well. But if you're not quite finding your answers there, I certainly always encourage you to contact your local BYK representative. They're more than happy to help talk with you about your application and help you determine what exactly is the best recommendation for your particular application. Excellent question.
Yeah, and I fully subscribe your answer. And one comment from me, of course, if there's anything where you are struggling finding the right additive, of course, you can even ask for some support in our lab. So as we mentioned before, you can send it to Wallingford and we will do some lab tests for you. Even in Brazil, Sao Paulo, we have our lab for supporting customers which are located in South America. So please, whenever you have any, if you need any support for some technical lab work, we are more than happy to do it for you. One more question for you, Brent. So you talked about the new silicone you introduced for car care application. Can you tell a bit more about the product?
Sure. I think it was probably maybe easy to miss last year in the year of COVID, with us not being able to maybe visit customers as often and tell people about it. But the BYK 9890. This is an aqueous emulsion of a silicone, and this is new. You don't find so many silicone emulsions within the BYK portfolio, but this makes it really nice for car care products and polishes. And it's really designed to help improve the water repellency and dirt pickup. You also get some really nice slip out of the polish. And because it's already emulsified, it's very easy to incorporate, and also which is kind of uncommon for silicones, it doesn't stabilize foam very much, which can be a problem with certain silicones. So it's a really nice product. Again, certainly recommend folks, you can find some information on the website, and again, if not, contact your local tech rep or Anna in Germany, or Shannon in the US, and they'd be more than happy to give you quite a bit more information.
Yes, of course. Yeah, so thanks a lot, Brent. I think we will answer all other questions by writing to you. You send us your email addresses, so we will come back to you as soon as possible. So thank you very much for joining today. In behalf of the entire team, we really appreciated your interest in our surface additives today. We are looking forward to welcome you back tomorrow, talking about rheology additives, and hope together we can explore the world of flow with you. So we wish you a wonderful rest of the day, and keep in touch tomorrow. Bye-bye.